morning everyone. My name is SHWETA YADAV and I am a student of IT college and my college roll number is 225008. So topic for today is motion of a rocket. A rocket motion is an example of the system of variable mass. The motion is based on the Newton's third law of motion and principle of momentum. It consists of a combination chamber in which liquid or solid fuel is burnt. The heat of combustion raises the pressure very high inside the chamber. So the hot gases are expelled from the tail of the rocket in the form of a jet with a very high exhaust velocity, and the rocket moves in forward direction. It exerts the force of action on the gas jet in the forward direction. There are the internal forces in the rocket and gas system. In the absence of external forces, the total momentum of the system is constant. The gas jet acquires the momentum in the backward direction and the rocket gets equal momentum in the forward direction. So, let m is the mass of the rocket plus fuel at the time t and v is its velocity. When an amount of mass dm is ejected from the rocket in time interval dt in the form of a gas jet, as u is the velocity of the gas jet and its velocity related to the rocket vr is given by vr is equals to u minus v, and let this equation be as 1. The velocity v here is the exhaust velocity. By the Newton's second law of motion, we have m dv by dt is equals to fe plus vr dm by dt, and this equation be as 2, where fe is the external force acting on the system and vr dm by dt is the force of reaction exerted on the system by the leaving mass. The force fe is the gravitational force and the air resistance on the rocket. Now, if we neglect the air resistance and change in gravity, then F is equals to mg. Now, if we put this in equation 2, then we have m dv by dt is equals to minus mg plus vr dm by dt. Okay, this negative sign is here because if the rocket motion moves upward, v is direction upward and vr g downwards, then we have m dv by dt is equals to minus mg minus vr dm by dt. So now dividing it with dt by m, we have dv is equals to g dt minus vr dm upon m. Now on integrating, when the motion starts at time t is equals to 0 with velocity v naught and the mass of the rocket and fuel is m naught up to an arbitrary time t, we get v naught to v, 0 to t and m naught to m. Okay, so we get v minus v naught is equals to minus gt minus vr log e m upon m naught. So from here, if we send v naught to this side, we get v is equals to v naught plus vr log e m naught upon m minus gt. Okay, we have taken negative as common. So where t is the time required for burning all the fuel, m is the final mass and v is the maximum velocity attained by the rocket. On neglecting g, we get v is equals to v naught plus vr log m naught upon m, and this is our final equation. Thank you and have a nice day ahead.